Hey, good morning, scientists. Or good afternoon, mattering when you're actually watching this. Um, but welcome to science class today. We are going to be diving into tectonic plate boundaries. So, what's happening underneath the Earth that is causing all of our landforms to be happening? I'm going to see a lot of connections to the rock cycle uh, that that we already covered um, as we try to deal with what are these larger geologic structures, earth structures that are caused, similar to um, what we were talking about with the Ouachita Mountains and Mount Pinnacle. So we're going to kind of go back and cover some things that were in the video that we just really haven't covered quite this year. So let's get rolling. All right, so first off, we got to start inside the Earth. All right, we start with convection currents. So remember, convection is this idea that they're going to have something that's going to be rising, and then cooling, and then falling, and then heating up, and then rising. Um, almost like something that is inside of a pot of water boiling and just continually rising, cooling, falling, heating up, getting less dense. And we get that same process that is happening here with these convection currents. And these convection currents are happening in the mantle, right, underneath the lithosphere. Remember, the sphere is kind of the rigid part, all right, of the Earth, and then we have this molten part here as well. So molten rock rises because it heats up, it takes up more space, and then it gets less dense, so it rises. And when it rises, it gets away from the heat source, which would be the inner core and the core, um, inner core and outer core. And as they go away from the heat sources, they're going to cool down. When they cool down, it's going to sink back down. If you think back to last year, when you did the convection currents in the oceans and in water, and we had the frozen ice. You remember the frozen ice cubes and the red food coloring with the heat source under it, and they just kind of started switching and flowing. It's a very similar process that is happening. So this is happening underneath us every day, all day. Has been happening for millions and millions plus years, and this repeats and repeats and repeats. And this material is cycled, just like the rock cycle talking about that. This is all molten. This is all melted, right? The whole time. All right. So what is the tectonic plate, though? Okay, so we got this convection current happening underneath the Earth in the mantle, and now what do we call these tectonic plates? Right. So a tectonic plate um, are just the lithosphere, the rigid part, and it moves around because of the convection currents. They keep cycling around, almost like they're floating. It's almost like to think about it like um, you're in a tube in the water, and then something happens underneath you, and it makes you move. So think about like if you've been in the lazy river like Magic Springs or Wild River Country, and you're sitting there, and there are these kind of jets that are underneath that push the water in one direction. That's like the convection currents. And then you sitting on top, it's like tectonic plates, and that's moving you around. And all these plates are these crazy big chunks of the lithosphere. All right, these pieces of the lithosphere that I put, that's why the word pieces is here, and those are slowly moving around, and they are moving because of what's happening in the mantle. These convection currents, all right, as well. So these convection currents are happening, and that's causing this gray part with the lithosphere to move around. So in this situation, you can see that these two pieces are pulling away from each other. All right, here. All right, and that is tectonic plates, and there's the logo I should have had you up. I should have had earlier, but there it is. So more heat here, which is causing that convection current to happen. All right, so these convection currents are moving, and here's a picture of the major plates, tectonic plates around the Earth. And these are just big pieces of the lithosphere, and their movement movement is happening. So you can see that we are part of the North American plate, which is this plate, quite large. Just there we are right here. And they are named after the land that's around them, most of them. Or like the Pacific plate is named after the Pacific Ocean because it covers up this most of the Pacific plate. All right. And so remember that the lithosphere is broken into pieces called plates, and they are constantly moving. All right, constantly moving. And what I like about this picture here is it also gives us little arrows that say what direction are those plates moving. So these plate boundaries where these plates touch, there are little arrows here that tell us which direction the plates are moving. All right, so you see these three, and if you look around, you notice there are basically three types of plate boundaries. Either the arrows are moving past each other, like two cars passing on a road, which is like right here, the North American plate and the Pacific plate, near where California is. Another famous one here is the Mid-Atlantic Ridge, right here. You notice it goes right through Greenland, right? And we'll talk about that later in the week. These are pulling up away from each other, right? So we have them sliding past. We have the ones going away from each other, or we're going to use the word divergent, but we'll talk about that later. And then another famous one is this one here. This is what's currently making the Himalayan mountains taller every day, very slightly. So year by year getting larger. This is these two plates are the Indian plate and the Eurasian plate are kind of smashing each other. This is very slowly. The Mid-Atlantic Ridge here, I believe that is on average about a little less than 3 centimeters per year. So that far every year. So they're moving, but they're moving really, really, really slowly. And these movements are really what's caused all the new rock to be formed. It's causing all of the things you see with earth and rock on the surface, except for erosion. So erosion is taking it back down, but it's creating all those landforms, mountains, trenches, valleys. A lot of these things are caused by, I guess, valleys are from erosion as well. But these plates that are moving around. And we're going to talk about one of these plates. One plate we're going to talk about is it's called a convergent. Convergent, all right? So it means coming together, right? Coming together. All right, and this happens when two plates are coming directly at each other, right? And these are going to cause mountains, volcanoes, and islands are all formed from a convergent plate boundary. All right, and there's three different types. The first one, look at here. These are when two plates come together in the ocean, pushed against each other. But this is all in the ocean. And when this happens, one of the plates is going to dive underneath the other, and all this friction with these plates passing each other is going to heat up this rock, all right, and then cause volcanoes. Now these volcanoes will be underwater though, so it's kind of hard to see them. And eventually, as they just keep bringing new rock, new magma to become lava, it's going to then pile up and cool down and solidify, crystallize into rock, and it gets higher and higher and higher, and then you get volcanic islands. Example of the Aleutian Islands that are in Alaska, that are that weird little kind of J shape coming off. I guess the other way for you, like this. The Hawaiian Islands are volcanic islands as well, although those are not happening on a plate boundary. That's a little different story, but it's very similar. So volcanoes underwater, all right, and then what happens is this plate goes down, it's just going to melt, right? It melts and goes into the sphere, does the convection currents, all right, as well, and then that way we can go back into the rock cycle. We have rigid rock here, which is all igneous rock that's going to be melting, all right, and then turn back into different rock. All right, the second kind of convergent plate boundary is when we have an ocean plate and then a continental plate. All right, and we're going to get volcanoes right here. The Cascade Mountains are some of the most famous volcanoes And that is all from here. You have the sand, the plate is the Juan de Fuca plate, and it is diving underneath the North American plate. The ocean plate's always going to go under the continental plate because the ocean crust is made of basalt. Made of basalt, and it's always going to dive under, and the continent's always made of granite. Right, those are all making rain. Same thing. It's going to dive down. It's going to melt, and then we're going to have heat and pressure here. It's going to cause volcanic activity as well. So the Cascade Mountains are in Washington, down to Southern California or Northern California. Mount Shasta, Mount Hood, Mount Rainier, Mount Adams, Mount Baker, and most famously Mount St. Helens, which blew in 1980. Right, as well. And the third type of convergent plate boundary is going to be when we have this happening on a continent, in the middle of a continent. And this is going to cause mountains, these folded mountains that created the Ouachita Mountains, 500, almost 500 million years ago. And those are going to come together like a car crash, and then they're heating. Since one's not really necessarily going to dive down underneath, although it does kind of do that, all right, it's going to hit and then just push up. It has to be more like this, right? And that gives us our mountains. The Rocky Mountains and the Himalayan mountains are doing that currently. The Rocky Mountains are not; those were formed a long time ago. Or the Himalayan mountains are more of a new one, as well. You can see they can hit, and then this crust is going to buckle, and then kind of push up. And this is convergent plate boundaries. Right, which is one of the three ways plates come together to create geologic features on the Earth as well. All right, so you can go back and rewatch and review. All right, so remember that how this works is, first off, there's convection currents inside of the Earth in the mantle. All right, they're continually cycling. All right, heating, cooling, and falling, heating, rising, cooling, falling. That's causing these plates above to shift and move. And sometimes they come together. When they come together, they can create volcanoes, islands, and mountains. All right, as well. So feel free to go back and rewatch any part of this video that you wish. And what I want you to do now is to go to Google Classroom 4.37, and there's a question just to answer. How are mountains formed from convergent plate boundaries? All right, and use 3 sentences to explain yourself. Go back and talk about convection currents make the plates move. All right, there are these large chunks of the Earth's crust that move around, that are like floating, and sometimes they crash together. When they crash together, right, one plate's going to dive under and cause friction and cause volcanoes, which can create mountains, which can create islands, and then sometimes they just crash together and then push up and create mountains, like the Ouachita Mountains or the Rocky Mountains, or currently the Himalayan mountains as well. If you have questions, shoot me a message. All right, good luck explaining how we get these geologic features.